Bismillahirrahmanirrahim. Assalamu alaikum everyone. I am Dr. Iftikhar with the second lecture in the quantitative techniques. I am sure you have learned a lot from previous lecture and you are eager to learn more about this, as you have come to know that this course is very important for you and it is equally important for each and every person who is interested in research. So I would like to start from the content that we are going to cover today. First, we will see that what are the potential problem in quantitative analysis approach, because if we say that this approach is without any problem, so it will not be correct. So like many other theories and techniques, it has also some potential problem, and as we will come to know about the potential problem, we will be able to minimize those problems. After this, we will cover the variables and their types. Although we will discuss variable in a special context, and we will show that which variable are more relevant to our research. After this, as this course is bit based on some mathematical and statistical fundamentals and concepts, so we will be just discussing the very basic concepts of mathematics like derivatives and some topics in statistics like the simple probability. After this, I will be giving you the summary. So first, let me start from that what are the potential or the possible problem in quantitative techniques. The first problem that if we face in the quantitative techniques is that the problems are not easily identified. In the previous or the yesterday lecture, I repeatedly said that this is the fundamental point. It is so important, and if we start well, it means that we have started our journey in a proper way. But on ground reality, it is a very, very difficult task, and there are number of problems that we have to face through this. It takes, what the problem may be, it takes lot of time, and there are mix-up of ideas, and it is very difficult for a researcher to find out the proper and the concise and the precise and concrete problem of his interest. The second problem that the quantitative techniques approach may suffer is the conflicting viewpoints. For example, on the same issue, there are conflicting remarks. For example, one student say that from the previous day example that C is a function of y, and he thinks that it is a linear function a plus by. The other may say that it is not the linear. So he may think that C is equal to a plus by plus cy square. So this is the situation. If you look at the first one, this one, you will come to know that this is the linear relationship. This shows the linearity between the independent variable, that is the income, and the dependent variable, that is the consumption. But at the same issue, if you go for the second equation, it is the quadratic equation that says that the relationship between the income and the consumption is not linear, but it is not linear, it is non-linear. So now the problem arises that there are conflicting views, conflicting remarks on the same issue. So now the researcher is in a fix and dilemma that which to select. So it is also a problem with the quantitative techniques. The next problem is beginning assumption. All the social sciences theories and statements and the hypotheses are based on some fundamental assumption. If these assumptions are fulfilled, then the theory becomes true, and if any one or all of the assumption of this theory or statement are lapsed, then the theory becomes impracticable. Similarly, it happens with these techniques. We start with some of the fundamental assumption. So it depends on the researcher that how he takes the assumption, one assumption, two assumption, which assumption he takes. It is totally based on his discretion, but ultimately he will have to go through the literature. He will, when he will go through the literature, he will be able to find out the assumption, and as the assumption will lapse, he will have to justify that what the problem may occur if one, two, or any one of the assumption is lapsed. The next problem that we can face is the fitting the textbook model. Although everyone gets an intuition from the textbook model, but the textbook model are necessarily, we can't say that they necessarily explain the true phenomena that on the ground realities. For example, if we fit the same consumption function on the developed societies as well as on the developing societies, no doubt the text model is there, but there is now a bit differences because the behavior of the developed society is a bit different, a lot different from the developed society. So fitting the textbook models, the researcher should know also the ground realities. If there are ground realities a bit different, he should introduce those realities into the model so that he captures the maximum possible information and his analysis becomes more and more practicable, precise, and relevant. The next problem with this quantitative technique is the validity of data. In quantitative techniques, we use the data, and data reliability is very questionable. Although the secondary data is available in many shapes, and the researcher is free from this bias that he has to use the data in the same way. But in survey or in collecting the primary data, there are many biases that we are going to discuss in our next discussion, the discussion that will follow after 1 or 2 lectures. So as yesterday in the previous lecture I said, the data reliability is directly related to the reliability of the analysis. So if you are able to get the reliable data from reliable source with precision, then you can say that your analysis is very good. But most of the time the data collection is very difficult. It is now become an art, and it requires a lot of expertise that enable a researcher to collect the data. The last problem, but not the least problem, is that hard to understand mathematics and statistics. Our quantitative techniques is based on the mathematical and statistical notation. Definitely to prove our statement or the theory, or you can say that to prove our claim, we will have to go through the mathematics, and we will have to derive some of the equations. We will have to make some of the complicated method to solve these equations. Similarly, we have to go through the hypothesis testing. We may face the type 1 error, type 2 error, and we may face many of the problems. So these are the problems that are concerned with the quantitative research approach. Now we come to know that what are variables and their techniques. As you know, the variables are simple quantities that keeps on changing, and in our discussions we denote them by the last alphabets of the English alphabets. So first of all, today that variable I am going to discuss, I will be discussing the 4 more important categories and types of the variables. There are many other types of the variables, but these types are more relevant to us, and we will be discussing that which type we are going to use up to certain level of analysis and what types we will be using after some time. So I am going to the blank sheet, and I will be explaining the ratio scale variable. So what is the ratio scale variable? Any variable that fulfills 3 basic qualities. What this means, any variable that will fulfill these 3 conditions, we will call that variable that is the ratio scale variable. The first is very simple, that if we take any two values, suppose we take two values of the same variable. I am calling the word same variable. Suppose the first value is x1 and the second value is x2. Now what the first condition is? The first condition is that the ratio of these two values should be meaningful. For example, if I say that x1 over x2, it should be meaningful. For example, if I say 10 over 20 is equal to 2, this is a meaningful ratio. 10 may be some value of the debt and the 20 may be the other value of the debt, or you can say that 10 may be the first value of the GDP in 10 billion into 1970, and 20 may be the 20 million GDP in 1980, or so on. The second condition, this was the second condition, and the second and first condition, the second condition is that the difference of these two values should be meaningful. For example, x2 minus x1, it should also be meaningful. What this means, for example, if I subtract 10 from 20, it is 10. If I just stick to the previous example, I can say that the difference between the GDP in the 2 years is now 10 million, billion, trillion, whatsoever. So the second condition is that the difference of these two values should be meaningful. The third condition is that these two values should be arranged. So what does this means? That x1 should be less than equal to x2. So what this means, we can rank these two values, which value is greater or which value is the lower. So these are three conditions. We will concentrate on these three conditions, and we will further go on the types of variable, and we will see that if a variable fulfills if one or two of these conditions are lapsed, then what we call those variable, and I will also exemplify from the routine matter of the issue. And now I am going back to the first was the ratio scale variable. If now you see what is the first condition, the first condition is simply that if you look here, that this is x1 over x2, this is the second condition, that their difference should be meaningful, the two values of the same variable. Do not confuse that x1 and x2 are two different variables. These are two values of the same variable. And the third condition is that they should be ranked. There are many variables that are ratio scale variable, and it is interesting for you that most of the time we will be talking about the ratio scale variable. The next is the interval scale variable. So I am just going to the next slide. So what this is, if any variable that fulfills the last two conditions. For example, what was the last two conditions? The second condition was that their difference should be meaningful, and the third was that they should be arranged. So what this means, now the first condition is not fulfilled. Although we can take their ratio x1 over x2, but it becomes meaningless. For example, if the time is 1950 and the other value of the time is 1980. So if I take 1950 by 1980, it doesn't matter. It is meaningless, it has no value. If 1950 and 1980 are two other values, then this is meaningful. But if it is time, if it is year, then it becomes meaningless. So what is the definition of the variable interval scale? That it doesn't fulfill the first condition. What this was the first condition? That the ratio of the values of this variable becomes meaningless. But it still holds the next two conditions. What the next two conditions are? The second condition was that their difference should be meaningful, and the third one was that they should be arranged, and we can say that the 1980 becomes later after the 1950. Then there is, if you see, that is the ordinal scale variable. Here, this is the ordinal scale variable. So we are going again there. And what is the ordinal scale variable? It doesn't fulfill the first two conditions. It only fulfills the last condition. For example, its ratio is meaningless and its difference is also meaningless. But it can be ranked that x1 may be less than equal to x2. What is the example of this? Example is that your grades, that A, B, C and D grade. Look at this. If we apply the first condition on this, for example, if I say that the ratio A over B, it is meaningless. It has no meaning. That grade A divided by grade B, it has no practical meaning. Similarly, if I say that A minus B, A and B are grade, it has also no importance or no relevance. And if I say that they can be ranked, and you know that the A grade is better than B grade, that is better than C grade, and that is D grade. So this is the example of ordinal scale variable. Other example we can give that the upper, middle, lower class and whatsoever, and it fulfills only the last condition. The last variable we are going to discuss is the nominal scale variable. What are the nominal scale variable? It is very easy to understand these variable, that they doesn't fulfill any of the condition that we have discussed previously. So I will just repeat 1, 2 and 3. The first condition was that their ratio is meaningless here in this nominal scale variable. The second, their difference will be meaningless. And the third one is that they cannot be ranked. For example, what is the example? If I take that the gender, if I take the gender, male, female, and I say as a single and divorce. Now if you look at these categories, if I take the ratio of the male divided by single, it is ridiculous. It has nothing meaning. And if I say that the male minus female, that is nothing. It is also very surprising, and you can say irrelevant. And the last one, we can't say that the male, female, single and divorce can be ranked, which is superior and which is inferior. So we cannot categorize them according to their values. So this these were the four major kinds and types of the variables that we are going to discuss. And most of the time, unless I make aware you that we will be talking about the ratio scale variables, that will be fulfilling all the three conditions. And at the end of this course, when we will be going into the logit and probit model, we may be going towards the nominal scale variable, and I will be introducing the concept of dummy variable. After this, now we go to the very simple concept of probability. What is the probability? Most of the time we are using the probability. Probability is the numerical statement, not the word statement, but it is the numerical statement. It assigns a specific numerical value about the chance that an event will occur. Events keep on occur in our routine life. But what is this? The probability is it gives a numerical value that this event will occur or not. For example, if I flip a coin, and I can say that the probability of getting head and tail is equal. So this is the numerical value. Equal mean 50-50, and if I say 0.5 for the head and 0.5 for the tail. So this is the probability, is the simply numerical value that we assigned about the chance that an event will occur. There are two basic rules regarding the probability. What are these rules? The first rule is the probability remains, this is the probability, it remains equal to or greater than 0 and less than equal to 1. What this means, if the probability if p is equal to 1, probability 0, it means this event is expected to occur for never. We are sure that this event will never occur. And if it is p is equal to 1, it means there are 100% chances that this event will occur, because there is only, you can say, this is the possible outcome. So the first basic theory, or you can say the rule about the probability, is that it ranges between 0 to 1. The more it converges to towards 1, the chances of occurrence of that event are more and more. And the more it converges towards 0, the probability of that event is going down and down. The second rule regarding the probability is that simple sum of the probabilities of an event is always equal to 1. For example, I am going to explain a very interesting example here. Before starting this example, I would like to again state the previous two statements. The first was that the probability always remains between 0 and 1. The second is that the sum of the simple probabilities of the event is always equal to 1. So how I explain this? For example, if we take the example of a petrol pump and we say that there is a person, you are sitting, I suppose you are sitting on the petrol pump, and you say, see the two variable, this is the quantity demand of, say, petrol or diesel, and this is the number of days, and I further suppose that you watch this phenomena for 200 days. So what happened on the first day? You felt that 0 petrol was sold for 20 days. That there were 20 days when the sale was 0. So what is the probability of the sale of 0 on the in this example? Simply it is 20 divided by 200, and it is equal to 0.1. What this shows, that out of 200 there will be 20 days on which there is a probability that no one will come to buy the diesel. Further, I say, going again, I say that there was sale of 1 liter, you can say 1 10 liter, and whatsoever, and I say that there were 40 days when 1 liter petrol was sold. 40 days you observed that 1 liter was sold. So what is the probability of this? 40 by 200, and it is equal to 0.2. Further you examined, you were sitting there, and further you examined that the 2 liter petrol was demanded on 50 days. So what is this? 50 divided by 200, and it is equal to 0.25. Further, I say that the 3 liter petrol was demanded on again 40 days. So the same probability as we previously calculated, 40 by 200 is equal to 0.2. Yes. And now if we add up this, these are the 20, 60, 110 and 160, and 40 days are still left. So we are just here, this is 4, and this is again, I say that it was also observed here, this is 40 by, this is 200. So this is 0.2. And look at, is there total number? If I total these, it goes to 80, 130, 170 and 190. Still 10 days are left. So I say that the 5 liter sale was on only 10 days. So what is 10 over 200, and it is equal to 0.5. Now our purpose is to prove that the sum of the probabilities of all these probabilities starting from here to this one, it should be equal to 1. So add up this 0.1 plus 0.3, this one 0.5, 0.7, 0.95 and 0.5 is equal to 1. So I can write here 1. So the second rule is proved that the sum of simple probabilities of an event is equal to 1. Now I will be talking about the types of the probabilities. There are two major types. The first is the objective probability. Objective probability is very easy to calculate. That what is the P event? Number of occurrence of the event divided by total number of events. If we say that the event will occur 10 times and the total number of is 100, then we can easily calculate that 10 divided by 100, it is equal to 0.1. For example, if I say that if we throw a dice, and what is the probability? Dice, Ludo ka dana. What is the probability of getting 1, 2, 3, 4, 5 and 6? I say that we want to see the probability of getting 3 on one throw. So its probability is 1 over 6. The each in one throw, 1 has the 1 over 6 probability, 2 has the same, and up to 6, these have the probability of 1 over 6. This is very easy. The second one is the subjective probability. How we came to know that the probability of getting 1 is 1 over 6? It is based on our previous knowledge. We know that when we throw a dice, there are 6 possible outcomes. So the total number of outcome is 6 and we are interested only in 1. So the probability of getting that event is 1 over 6. If we have no probability or the previous information or we have the historical information, then we are in a fix and we cannot calculate the objective probability. Then the problem is that comes the subjective probability. What is the subjective probability? We have no logic from the history or the previous phenomena, because this phenomena is not happening on like a calculated version, and we can't say that this will the probability of happening this event is such. For example, if I say that what is the probability that floods will come? We know that floods keeps on coming in all the countries. But there is no, we don't know that there are 6 outcomes, 7 outcomes, 10 outcomes, and we cannot calculate that 2 by 10 is the probability. We just are looking on this and we will find some other method to find the subjective probability. The other maybe, what is the probability that depression will come in the economy? You know that the depression keep on visiting the economies, there are business cycle, but we can't say. We just say that the crisis is going to appear. But what is the probability that in 2020 the economic crisis will come? We are unable to say, because we have not a strong, certain, concrete, precise information about this cyclical fluctuation of the crisis. The other may be an interesting question, that which party will win the coming election in Pakistan. Now there is election time in Pakistan, and you know in a couple of weeks this government is going out of office and the new government will come. Now there are many parties that are competing to win the election. Now we can just say that who is going to win. There are more chances. For example, we say the PMLN, the PPP and the PTI. But what is the probability? It is very difficult, because this is not the objective probability, this is the subjective probability. Now the immediate question comes that how we will estimate or how we will calculate this probability. Then we go for the opinion polls. As you are listening on the news and reading in the print media, that there are number of surveys, for example the Gallup surveys. What they do, they make the total number and then they put their question to a certain number of respondents, that is the total number of respondents, and then if 20 out of them say that A, B, C or party is going to win, then they divide that option with the total number of the events. So in this way the subjective probability comes. So before going further, I will explain that what is the difference between the objective and the subjective. The major and the fundamental difference is that the objective probability is based on the previous knowledge. The previous knowledge is irrefutable and we are 100% sure that when we flip a coin, there is definitely either head or tail. So we give a probability 1/2 or half to the head, and we give assign probability half to the tail. But in the subjective probability, our previous or historical information is very weak, and we cannot depend on this information. The next is, what are the mutually exclusive and collectively exhaustive event? Mutually exclusive event, if only one of the event can occur on any one trial. For example, if we conduct only one trial and there is the possibility of that only one of the 2 or 3 or 4 or 5 or 6 option, only one can occur, this is the mutually exclusive event. For example, if I throw a coin, if head comes, tail cannot come in that event, and if tail comes, the head cannot appear. So these are the mutually exclusive event, that the appearance of one event categorically restrict the appearance of the other variable. It precludes the probability that the event will occur. So the mutually exclusive events are those events that only one of the events can occur in one trial. And what is the collectively exhaustive event? If the events are said to be mutually exhaustive if the list includes all the possible outcomes. For example, if we are talking about the flip of the coin, if we give the option that it is head, this is head and tail, this is a mutually exhaustive event because it includes all the options. Similarly, if we throw a dice and we say that either there will be 0, if we throw a dice when we play the Ludo, that the dana is called the dice, so it has 6 outcomes, 1, 2, 3, 4, 5, 6. So this is the mutually exhaustive event that includes all the possible outcomes, and we say that the A event, if we take its union with B event, and it is equal to the total population. Not mutually exclusive event. What are the not mutually exclusive event? It is totally against the mutually exclusive event. For example, two events can occur at the same time. So what this is, that the occurrence of one event cannot restrict the occurrence of the other event. There is the possibility that both the events can occur at the same time. If there is the probability that both of the events can occur at the same time, then they are not mutually exclusive. Interestingly, how this can happen, we say that if you know about the playing cards, there are 4 colors. And if I say that drawing 5, the number 5, there are 4 number 5s in spade, clubs, heart and diamond. So there are 4 5s, and I say that drawing a 5 and drawing a diamond from a deck of cards, it can be both 5 and diamond. For example, if I draw a card, I say that it should be either 5 or it should be a diamond. So if you see, it can be both. For example, randomly selecting this, if I draw a card on the card it is written 5 and it belongs to the diamond, then it means that both the events have occurred at the same time. So such kind of events are called not mutually exclusive events. Now our concern is to add the probabilities of these events. So how we can add mutually exclusive event? It is very simple, that when the two events are mutually exclusive, so we simply add the probabilities of both the events. For example, if I say that what is the probability, if I say and I suppose that the events are mutually exclusive, and if I say that what is the probability of event A or event B, I suppose that there are only two events, that what is the probability that event A are occur or the event B? It is very simple. I can add these, that the probability of A is plus probability of B. For example, if I say the head and tail, the probability of head is 1/2 and the probability of tail is 1/2, and it is equal to 1. So it is very easy to add the mutually exclusive events because there is no overlapping of the probability. Both the events, if one event occur, it restricts the other, and they are independent here. We add one probability with the other and we get the probability of happening A event or the B event. If I want to show this by the Venn diagram, you can see that this is the A event and this is the B event. So what this means, both the events are not overlapping with either. It means the probability of happening event A is totally different from, is independent from the probability of happening B. So what this means, 1/2 plus 1/2, it will be equal to 1. This is the addition of the mutually exclusive event. If I go for the not mutually exclusive event, then we use some different formula, and I am going to explain that what is that formula. Suppose that our events are not mutually exclusive. I will be giving you the example. First I will be writing the formula, and then I will giving you a very interesting example, and I will also showing with the diagram, that is the Venn diagram that I have just completed in case of the mutually exclusive event. For example, we suppose that our events are not mutually exclusive, and we try to find the probability of event A or event B. I am just keeping myself so simple that I am supposing that the only two events can occur. So how this can happen? The probability of A or event B is equal to probability of A plus probability of B minus probability of A and B. So this is the formula to add the probabilities of the not mutually exclusive event. If I want to show with the diagram, you can see if this is the A event, this is event A, and now you can see there is some of the overlapping with the B. There is some of the overlapping with the event. This is event B. So now you can see that there are two probabilities of event A, event B, and if I just color this, this is the probability that anyone can be occur, both can be occur. So this is this probability that we are deducting at the end, because if we add up these, we are adding something extra. So we have to subtract this from the total probabilities that we summed in case of probability of A plus probability of B. So I would like to give example. Suppose there are 30 students in the class, and 17 are boys and 13 are girls. On a test, 4 boys and 5 girls made an A grade. Listen again, that there are 17 and there are 30 students. If you look at here, this is the 30 student, out of which 17 are male and the 13 are female. And there was a test, 4 of the boys and 5 of the girls made an A grade. If a student is chosen randomly, if we select one of the student out of these 30 students randomly, what is the probability of choosing a girl or a student with A grade? First we will find the probability of choosing a girl, then A, and then we will be subtracting the probability of girl and the A. So I will be completing it here. So what this means, so we want to find the probability of a randomly selected student, and we are going to find that it may be a girl or A grade student. So what is this? The probability of selecting girl or students with A grade is equal to probability of girl, selecting girl, plus probability of A, selecting a student with grade A. There are students who also have A grade and they are male, minus the probability of girl and A grade student. So if you look what is the probability of selecting girl, there are 13 girls and the total number is 30. So this is the probability that when we select a student randomly, that will be the girl. And what is this? There are 9 people who have A grade and there are total number of students 30. So out of 30 there are 9 A grade holders. So the probability of a student who will be selected and he or she may have the A grade 9, that is the 9. But we have to still from deduct, because we are interested in finding that the girl or the A grade. So what will be the probability of? So we will be subtracting from it that there are 5 male students with A grade and 5 over 30. 5 over 30. So what this means, this is 20 over 30, 22 over 30 minus 5 over 30 is equal to 17 over 30. So this is the probability. The events were not mutually exclusive. So this is the probability that if we select a student randomly out of the 30 class, the students may be girl or it may be the A grade holder. Now these were some of the basic concepts in the statistics. Now we are going to discuss some of the basic concepts in mathematics. So first of all, I will start from the derivatives. What is a derivative? Derivatives are extensively used in many of the discipline. So simplest definition of a derivative is that the derivative measures a change in a function. The simplest one is that it shows a rate of change in any of the function. So if I make a function, this is function before you, this is the x, this is the dependent variable, this is the y, this is the dependent variable, and suppose this is our function. And I say I want to see the rate of change at this point. So if I, between this point and this point, so if I connect this one here, I also connect this one here, and I connect this to so what is this? What is the derivative? It simply measures the rate of change in a function. If I make a function here, so this is the x, the independent variable, this is the y, dependent variable, and I say that this is a function and y is a function of x here. So if I want to say the rate of change at point this and between this point, so I will just connect this one here and I will connect this one here. Similarly, I will connecting this towards the y-axis. y-axis, and similarly I will be connecting this to up to here. So from here to here, this change in y, delta y, and this changes delta x. So if I take the change in y, delta x here, so this is delta x. So without going into the details of the limits concept, I will simply say that it is equal to delta y over delta x. What this means, change in dependent variable, that is y here, with respect to change in the independent variable, that is the x. So this is the derivative that measures the rate of change in the dependent variable with respect to the independent variable. Simply speaking, that the derivative measures the rate of change. So we will be discussing some of the different rules to make derivation. Before going further, I will just show the concept of maximum and minima. So what these concepts are, these are based on the derivative, but I will just show that what are the conditions for this. For example, if this is the graph before you, if this is the graph and I say that this is a function, this is x, this is y here, this is y is a function of x. There is one point that is the maximum at this is, I want to say this point A. This is the maximum point, but how we can show that this is the maximum? There are two conditions that can be fulfilled, and then we will say that this is the maximum, and we take help from the derivative concept. So at point the first derivative dy, the first derivative dy over dx should be equal to 0. What this means, at this point the function is constant. It is not changing. If you see after reaching the maximum, it starts, then it's a downward slope. So the first derivative at the point A should be equal to 0. And the second derivative, if we take the same function, again we take derivative of that function, that dy square dx square, it should be negative, less than 0. We will be proving this, that this is the first condition. The first condition is called the necessary condition. This condition is called the necessary condition, and this condition is called the sufficient condition. So these conditions are for the maximum, that the point A is at the maximum. If I take a function and I say that I want to find the minimum of this function, so we can find this function using the derivative techniques. This is x, this is y, and this is, if this is the function and I say y is a function of x, and I say that now this is the point, and I say that this is the minimum point. So what this means, the first condition at this should be, that is the necessary condition, that the dy over dx should be equal to 0. The first derivative at this point should be equal to 0, and the second d square y over dx square should be greater than 0. It should be positively sloped. If you see here, up to here the function is going down, decreasing, and after point A it is increasing. That why that the sufficient condition becomes here, that the second derivative should be greater than 0. So just to remember, I will just repeat these two conditions. That what is the derivative? Simply the derivative measures the rate of change of a function. What is the minimum or the maximum? Minimum of a function, a minimum point on the function is that it fulfills two conditions. The first condition is the necessary condition, that the first derivative at that point should be equal to 0, and the second derivative, if it is maximum, the second derivative should be less than 0. The function should start declining. And as against this, if we are interested in finding the minimum point, the first condition will remain the same. The necessary condition shows that the first derivative should be equal to 0, dy over dx should be equal to 0, and the second derivative should be now positive instead of the negative. Now I will explain some of the rules. These are the rules that helps us in taking the derivatives. So the first rule is called the constant function rule. What is the constant function rule? The first rule is constant function rule. Constant function rule. What this rule? The derivative of a constant is always equal to 0. Very simple, that the derivative of any of the constant is equal to 0. For example, if y is equal to 4, I take the derivative of y, dy over dx, it will be equal to 0. So the first rule is, and it is called the constant function rule, the derivative of any constant is always equal to 0. So the second rule is, that is called the power function rule. The second rule of derivative is, that is called the power function rule. Power function rule says that if y is a function of, y is equal to x, if you see that if I take this x, I can say that here is its coefficient and that is a, and here is its power, that is n. So the derivative of in this rule is dy over dx is equal to multiply the coefficient with the power and subtract subtract 1 from the total power. For example, it will be equal to a multiplied by n x power n minus 1. This is called the function, and this is called the power function rule. It will be equal to a n x power n minus 1. So I take the example and then I clarify. So for example, if y is equal to 4x power 5. Now there are two variables y and x. Y is the dependent as usual and x is the independent. Now instead of a, there is 4. That is the coefficient of x. And instead of power n, there is 5. So if I follow the previous formula, it becomes multiply the coefficient with the power. 5 multiplied by 4 is equal to 20. And x power 5 minus 1, and it will be equal to 4. So it will be equal to 20x ki power 4. So this is the second rule, that is called the power function rule, and it is widely used and it is the basic concept. So by now we have learned two rules. The first is that the derivative of a constant is always equal to 0, and the second is the power function rule, that y is equal to if y is equal to x, then we multiply by, when we take the derivative, we multiply the power with the coefficient and we subtract 1 from the power. The next rule is called the addition rule, addition or subtraction rule. Addition, the third rule of derivative is addition or subtraction rule. What this says, for example, of say y, I say that y is equal to 3x plus 4x square. So now at the right side there are two parts, two terms. Suppose I say, so I suppose that u is equal to 3x and v is equal to 4x square. I have just supposed. So what is the formula for this addition is dy over dx will be equal to du over dx plus dv over dx. So this is the rule for this. So what we say, if I just add the subtraction sign here, then it becomes the addition as well as the subtraction rule. So just applying this formula to here, now we see that what the result comes. So I will be using this formula, and then I will be showing that this is the addition or the subtraction rule. So for example, I take a function that is y is equal to 4x plus 20x square. So now, as I just previously explained, that u is equal to 4x and v is equal to 20x square. So what is du over dx here? It is simply 4. And what is dv over dx? It is 20 multiplied by 2, it is 40x. So this is, and then dy over dx will be just addition of u and v, that will be 4 plus 40x. And if there is subtraction, it will be similarly, we will be subtracting this from the previous one. And the next rule is the product rule. Very interesting rule, and a bit, you can say, a bit difficult from the previous one. What is the product rule here? Product rule, formula for product rule is that dy over dx is equal to u. Now we will suppose u and v. U multiplied by dv over dx plus v du over dx. So this is formula for the product rule. Suppose we say that there is y is equal to 3x plus 2 multiplied by 2x square. Now what we do, we suppose that u is equal to 3x plus 2 and v is equal to 2x square. So as we have to use, if you look at here, I have the value of u here. This is u value we have, this one v value we have, and now we need du over dx, and here here dv over dx, and here du over dx. So what is there if I take the derivative here? So this is du over dx is equal to 3x, because the constant, this 2 will be equal to 0. Here dv over dx, using the power rule, it will be equal to 4x. Now we have to just put these values into the formula. For example, instead of u, I have the value of, for example, now dy over dx will be equal to, what is u? U is 3x plus 2, and what is dv over dx? This was u, this is dv over dx. So dv over dx is here 4x. So I will multiply it by 4x plus v. The value of v is, look at here, the value of v is equal to 2x square. So v is equal to 2x square multiplied by du over dx, that is equal to here 3x. So this is 3x. Now it is simple multiplication. This will become equal to 14x square plus 8x plus, if I multiply 6x square, is 6x cube. If I now add this up, this will be 6x cube plus 12x square plus 8x. So this is that how we find the values of the derivative with the quotient rule. And now this is the rule that we find the values of using the product rule. The next is the quotient rule. The rule number is 5 is quotient rule. So this is 5 quotient rule. Quotient rule. Again, supposing x, u and v, this becomes dy over dx, and it is equal to, now v comes first. As compared to the previous product rule, v comes first, and this is du over dx. Now instead of plus, it is minus. This is u dv over dx, all divided by x square. So what this means, for example, we take an example and we say that y is equal to 2x plus 3, 2x plus 3 divided by 4x plus 2. Now immediately we suppose that u is equal to numerator and v is equal to denominator. So suppose here, suppose u is equal to 2x plus 3 and v is equal to 4x plus 2. Now if you look at the formula, we need the values of v, u as well. This is the v square. So we need the value of v, u and dv over dx and du over dx. So what is this? First we find from here du over dx. So du over dx is equal to, I am finding du over dx from here, it is equal to 2. It is equal to 2. And what is dv over dx is, I am finding this value from here, this one. So dv over this is dx is equal to 4. Now I can substitute the value into the above formula. So dy over dx will be equal to, first write the v. So we have the value of v here, 4x plus 2, 4x plus 2 multiplied by du over dx, and this is the value of du over dx, and this is 2. This is the minus, so minus. Now I need the value of u. The value of u is 2x plus 3. 2x plus 3, and I multiply it with dv over dx, that is the value of 4 here. The value of 4. And I divide all this term by v square, and what is v square? 4x plus 2, this is v, and this is whole square. Now if we solve the above, it will become 4x multiplied to 8x plus 4 minus 8x minus 12, and divided by 4x plus 2 whole square. So now it is equal to, this will cancel out with this, and it will be minus 8 divided by 4x plus 2 square. So this is how we use the quotient rule here. Now the next rule is chain rule. What is the chain rule? Here another interesting story. Chain rule, what this says, here y is a function of a variable u, and interestingly u is further a variable of x. Now y is a function of u and u is a further function of x, and we are interested in taking the derivative of y with respect to x rather than u. So what we use the formula, for example, if we want to take dy over dx is equal to dy over du multiplied by du over dx. This is formula for the chain rule. I am going to explain it by one of the example. So for example, if y is equal to 3u square. Example, if y is equal to 3u square, and we further find that u is equal to 4x plus 5. 4x plus 5. Now look at the formula here. We need dy over du. We can get dy over du from here. So what is the value of dy over du here? Dy over du is equal to 6u here. And we can find the value of du over dx from here. So the value of du over dx from the below function is 4. And now just putting the value into the chain rule, dy over dx is equal to dy over du is equal to 6u. So it is equal to 6u multiplied by, this is 4. Du over dx, here this is du over dx multiplied by 4. What this means, it will equal to 24u, and now we have to replace the value of u that we have taken. So now it is 24u, so we will replace the value of u here, 24, and what is the value of u? 4x plus 5, and if we multiply it become 96x plus 120. So this is the chain rule, dy over dx is equal to 96x plus 120. Chain rule is very interesting because in the previous all the rules, the y depends on the independent variable and there was not another function. But in chain rule, y depends on one variable and that variable also depends on further one variable, and we are interested in taking the derivative, and we are interested to measure the change in y with respect to the last variable, that is the x. So this is the story behind the chain rule. Now I will be explaining the inverse function rule. So this is the inverse function rule. This is very simple. For example, if y is a function of x and I am now interested in change in x with respect to y, not change in y with respect to x. So what can I write? I can write that x is a inverse function of y. This f minus 1 is the sign for the inverse function. So what is the formula for this is, for example, if we have given this the simple function and we are interested in dx over dy, not dy over dx, then the formula for this is that it is equal to 1 over dy over dx. Simply we will find dy over dx and we will divide it by and 1 will be divided by this our product, or what we will be getting the value. For example, if y is equal to 3x and we want to measure the value of dx over dy. So first we will find dy over dx, that is equal to 3. And now according to the formula of this formula, what we will be doing, dx over dy will be equal to 1 over 3. So the derivative, the inverse function rule enables us that we can find the inverse relationship between the dependent and the independent variable. What this means, our independent variable becomes dependent and dependent variable becomes independent. So in this case we use the inverse function rule. That is very easy, that dx over dy, if we want to we are interested in measuring the change in x with respect to y, but the function is giving that y depends on x, then we use the formula that dx over dy is equal to 1 over dy over dx. The last rule in this, not the least, but we are just confining ourselves to our relevant discussion. The last rule is related, that is related with the partial derivative. Partial derivative, these are very important. What are the partial derivative? Partial derivative. What this means? Partial derivative means that now our dependent variable not only depends on one independent variable, but more than one independent variable. For example, if y is equal to x1 plus x1 x2 plus 2x cube x square. So what this means, now you can look at here that this is one variable, independent variable, and x2 is another independent variable. So now we want to see the partial effect of one variable, that x1 or the x2 on y. So when we use this technique, this is called the partial derivative. In partial derivative, what we say, if we are interested to measure the change with respect to one variable, for example, if x1, we will totally ignore the x2 if x2 terms is joined with the other terms with the sign minus or plus. Why we do this? This plus shows that the x2 has its own independent effect on the y. But here we cannot ignore the x2 here, because it is joined with the x2 and it has some effect, joint effect on the y. So for example, if I take and we use this notation rather than d, that this is called the partial derivative. So if I am interested to partial y over partial x1, now the x2 will be omitted if it is in with the sign plus or minus. So what is this? The derivative of x1 is equal to 1, and here the derivative of x1 x2 is equal to x2, and this whole term will become 0. So this derivative becomes 1.x2. And at the same time, if I want to take the partial derivative with respect to x2, now I will hold constant x1, and I will ignore or drop, or you can say kick out the x1 if it is connected with other terms with plus or minus rule. So curly y over curly x1 is x2 is equal to, now this x1 will drop out definitely because it is connected with the positive sign, and now from here I can take the derivative of x2 and this is x1 plus 2 square, and this is 4x, this is 4x2. So this is the story behind the partial derivative, and we are interested in this. So these were the techniques we used here, and I think it is time to close and wind up the lecture, and I will be giving you the just summary of this, and then I will be concluding. We started from the quantitative techniques, and we showed that the quantitative techniques are not free from the bias. So what are the bias? There are many bias in quantitative techniques. The first bias was, if you remember, the first bias was simply that it is difficult to identify the problem. Then there was the data problem. Then there were many other problems with respect to this. Then when we came to the variables, and variables, we talk about 4 variables categories. The first was ratio scale variable. I will again concentrate on the ratio scale variable because most of the time we are interested in the ratio scale variable. It doesn't mean that we cannot include the other variable into our model, but we can include, but at this time our discussion is only restricted to the ratio scale variable. What are the ratio scale variable? By now I think you are fully aware of this, that it should fulfill the 3 characteristic or 3 condition. The first is the ratio of the 2 values of the variable should be meaningful. The second is the difference of these 2 values should be meaningful, and the third is that they could be arranged that whether one is greater or the other is greater. And the simple example is that the many variable are the ratio scale variable. For example, if I take the taxes, these are the ratio scale variable. Inventory, profits, and interest rate, these are the ratio scale variable. Then after this, if you remember, if I go to the first slide, the slide related to this one, there was the interval scale. Interval scale means that it doesn't fulfill the first characteristic, and then there was it fulfills the other two characteristics, and then there was, after this ratio scale variable, there was the ordinal scale variable. These variables skip the first two conditions and only fulfill the last one, and I gave the example that the grades are example for this. Then there was the nominal scale variable, and what was the nominal scale variable? It was showing that it doesn't follow any of the three conditions we discussed. Then we went towards the probability, simple concept. What is the probability? The probability is the numerical value, numerical statement of the occurrence of an event. That event will occur, and there were mutually exclusive event if the occurrence of one event precludes the occurrence of the other event. They are called mutually exclusive event. Then there was the not mutually exclusive. It means that both the event can occur at the same time. So how to add this? When I showed with the diagram, the Venn diagram, the mutually exclusive events have their circle independent of each other, but in not mutually exclusive event there is overlapping, and there is some common probabilities, and we use different formulas. I think you are well aware by now. You are well aware of this. There are two rules for this probability. The first is the probability always remains between 0 and 1. It can never go to minus. It cannot cross the 1. What this means is that if the probability, there are two limits, 0 the lower limit and 1 is the upper limit. What this means, if the probability of an event is 0, it means it is never going to occur. And at the same time, if the probability of the event is 1, there is expectation that this event will occur 100%. The second rule in this was that if we sum the simple probabilities of the event, then its total should be equal. I gave example. If I again want to give some example, I will simply say that if we flip a coin, the probability of head is 1/2 and the probability of the tail is 1/2. 1/2 plus 1/2 is equal to 1. Then we further went towards the subjective and the objective probability. Objective probability is very simple to measure because we take the number of occurrence of an event divided by the total number of events. So this is very simple, and most of the time we are concerned with this type of probability. But there is subjective probability. Subjective probability becomes a problem because we have no background information and we have no sufficient information, the historical data. So what we do, we make survey, we conduct survey, and then we take the total number of respondents, and then we get the probabilities that what is going to happen. As I exemplified, that if we are going to see that which party is going to win the election in Pakistan in the coming election 2013, then we will be making surveys, and I am sure you are going through many of the surveys on the different news channels. Then we just discussed the some of the basics concept in the mathematics. What were these concepts? The first concept was the derivatives. There are many other concepts, but we are just discussing the concepts that are more related to our discussion. The first concept was the derivative. Derivative is simply the rate of change in the function. On the basis of derivative, we can find the maximum point of a function or the minimum point of a function. For this, we discussed two categories. We discussed two conditions. The first was that the first derivative should be equal to 0. The second derivative, for the maximum it should be negative, and for the minimum it should be positive. We discussed different rules, and then we came to know that when there are different conditions, how we come to know how we calculate, we derive the function. And this was the total story from me for this lecture. So goodbye and Allah Hafiz. Thank you very much.